Hello again. So today we'll continue with lesson 4, fraction addition. Okay, last time we already talked about two cases. The first case, we talked about adding two or more fractions and all of them have the same denominator. And the case 2, we talk about we add different fractions together, but they have a different denominators, and one of them, one of the denominator, denominators has a no, not has, is a multiply of the other denominators. Okay, so and today we'll talk about case 3. Case 3, like all fractions have different denominator. So all fractions have a different denominators and none of them is a multiply of all others. Okay, so it means it's not case 1, it's not case 2. So in this case, what we have to do, we have to find the least common denominator by using the prime product method. What is a prime product method? We already talked about it in other lessons, but I will talk about it again while we go over examples. Okay, and after we find the least common denominator, and then we'll make all fractions to become new fractions having the same denominators, and then we can add the top parts together. Okay, so now let's go over one example. Okay, we go from the simple example first. So let's say we have a 1/2 plus 3/5. So in this case, we can see those fractions, they do not have the same denominator, right? Because 2 different from 5, right? And 2 and 5 are not multiply of each other, right? 2 cannot divide by 5, 5 cannot divide by 2. So it means they are not multiply of each other. So in this case, we have to find the least common denominator, okay? So we need to find the least common denominator. How can we find it? We using the prime product method. So first, we write 2 and 5 as products of prime numbers. Okay, so now you see 2, because 2 is already prime number, so we only can write 2 as a 2 times 1, right? And then 5 is also prime number, so we only can write 5 as a 5 times 1. Okay, that's a step 1. So step 2, okay, so we'll make the least common denominator will be the product of all prime number on different, let's say, on different prime number with the highest power. So what is the highest power? I give you an example, okay? So if you have a okay, so what is the highest number? For example, in this case, 2 equal to 2 times 1. So 2 here has a power 1. Okay, 1 here has a power 1. 5 equal to 5 times 1. So 5 here has a power 1. So 1 here has a power 1. So the least common denominator, product of all different prime numbers. So all different prime number here is a 2 times 5, right? We don't care about 1, okay? 1 does not matter. We don't need to care about 1. So we have a different prime number here is a 2 and 5. And the highest power of 2 in this one is 1. The highest power of 5 here is also 1. So that's why it is just a 2 power 1 times 5 power 1. Okay, power 1 we can write like this. Here's a number 1 here. But actually this one is not important in this case because power 1 does not mean anything. So that's why I don't write it. So now the least common denominator is 10. Okay, so after we find the least common denominator, now we make or we change the original fractions into new fractions having the same denominator. In this case is 10. Okay, now we'll change one by one. So 1 over 2, how can we change 1 over 2 to become a new fraction with the denominator as 10? So if you notice, so 10, in order to make 2 become 10, so it means you have a 2 increases 5 times, right? So it means we need to times 2 with 5. And because you times the bottom part with 5, you need to times the top part with 5 as well. So that's why we have a 1 times 5 over 2 times 5. And it equal to 5 over 10. So now we already have a new fraction that have a denominator as 10. Okay, that has the same value as the original fraction 1 over 2. So keep going for the second fraction, 5 over 3 over 5. And we want to change it into the new fraction with the denominator as 10. So it means we have a 2 times 5 with 2. And because we times 5 with 2 here, we have a times 3 with 2 as well. So we have a 3 times 2, 5 times 2. And we have the new fraction as a 6 over 10. Okay, so now for the second fraction, we have a new second fraction, 6 over 10, that has the same value as the original one, 3 over 5, but it has the denominator as 10. Okay, so now both of them have the same denominator, so the remaining work is easy. We just add the new fractions together. Okay, so 5 over 10 here come from 1 over 2. Okay, 6 over 10 come from 3 over 5. Okay, so now we just add the top part together. And then just keep one number 10. Okay, for the bottom part is 11 over 10. And in this case, the top part is greater than the bottom part, so you can convert it into mixed number, or you can keep unchanged. It depends on the question in the test you have. So if they ask you to convert it into mixed number, because the top part is still greater than the bottom part, then you only need to do the long division. 11 divided by 10. So 11 divided by 10, so it's only can give you the quotient 1, right? You cannot say 2 because 2 times 10 is 20. It's greater than 11, so it's wrong. So we only can take 1. So 1 times 10 is 10. 11 subtract 10 is 1. So here, 1 here is a remainder. 1 here is a quotient. And 10 here is a divisor. And the answer is 1, quotient here. Remainder go here. And then divisor go here. So that's the final answer. Okay. We go over another complicated example. Let's say we have a 1 over 36 plus 4 over no, 36 is too big. Maybe I give something easier. So 1 over 3 plus 5 over 20, not 5, 7 over 20 plus let's say 5 over 12. Okay, so you can see those fractions, they have a different denominators. So 3 different from 20, different from 12. Okay, and they are not multiply of each other. So 12 is a multiply of 3, but 12 is not multiply of 20. Okay, so we don't have a denominator that is a multiply of all others. Okay, so 20 is not multiply of 3 because 20 cannot divide by 3. 20 is not a multiply of 12 because 20 cannot divide by 12. 12 is a multiply of 3 because 12 can divide by 3, but 12 is not a multiply of 20 because 12 cannot divide by 20. That's why we don't have a denominator that is a multiply of all other denominators. Okay, so it means it's case 3. So we have to find the least common denominator by using the prime product method. Okay, and the prime product method is mean we have to write each denominator of each fraction into a product of prime numbers. Okay, we start with the first denominator 3. So 3 here is already a prime number, so we only need to write as a 3 times 1. Okay, and the power of 3 here is 1, and the power of 1 here is 1 as well. Okay, so now we go with 20. So how can we write 20 as a product of prime number? Okay, so we using the chi method. So you know 20. Okay, we check 20 can divide by what prime numbers? Okay, so 20 can divide by 2. And if it divides by 2, then the result is 10, right? So in 2 and 10, 2 is a prime number. So we don't do anything further with 2. So now 10 here, 10 is not prime number. So it means we need to keep, we need to continue breaking it down. Okay, so 10 is not prime number. So it means we can break 10 as a product of prime numbers. So we check with 2. Yeah, it's okay, it's good. So 10 can be written as a product of 2 and 5. Okay, so after you break down 10 become a product of 2 and 5. So 2 is prime number and 5 is prime number. Okay, so nothing else to do further, because the last digit is 2 and 5, and both of them are prime numbers. We cannot break any further. So how many number 2s we here? 1, 2. And how many number 5 we have? We have here just one number of 5. So 20 we can write as 2 times 2 times 5, right? Two prime numbers 2 and one prime number 5. Okay, or you can write, because we have a 2 number of 2, so it means we can write it as a 2 power 2 times 5. So here the highest power of number 2 is 2, and the highest power of number 5 is 1. Okay, because only one number 5. Okay, and now we will okay, so now we'll keep going with the denominator 12. Okay, 12. So 12 is not prime number. It means we can write it as a product of prime numbers. Okay. So 12 can divide by 2. Yes. And the rest, the quotient is a 6. Okay. So 2 and 6. 2 is already prime number. So circle it. It's done. We cannot do any further with it. So now 6. 6 is not a prime number, right? Because 6 can divide by 2 and 3. So it means we can break it down further. We can break it further. So 6 can be written as a product of prime numbers. So 6 can divide by 2 is 2, and 6 divided by 2 is 3. So 6 can be a product of 2 and 3. Okay, and now you check 2 is prime number. Yes. 3 is a prime number. Yes. So nothing else you can do. Just circle them. Okay. So how many number 2? 2 number 2. So write 2 times 2. How many number 3? 1 number 3. Just write 1 number 3. Okay. And because we have a 2 number 2, so you can write as a 2 power of 2 times 3. Here, the highest power is of 2 is 2. And the highest power of number 3 is 1. Okay, because we only have a 1 number 3. So now we already write all the denominators as a products of prime numbers. That's the first step. And the second step is oh, I need to change this. Write own denominator as a product of prime number. Okay, and now so after we write all the denominators as a products of prime numbers, now we need to find the least common denominator. And the least common denominator, as I said above, it will equal to the product of all different prime numbers with the highest power. Okay, so here let's check how many different prime numbers we have. So for 3 equal to 3 times 1, so we have a prime number 3. So for 20 we have a prime number as a 2 and 5, so they are all different. So times 2 times 5 here. And for 12 we have a 2 and 3, right? But because the 2 and 3 already appear here, so we don't need to rewrite, we don't need to write here. Okay, because 2 and 3 appear in 12, and 2 and 3 also appear in 20 and 3. So that's why they are the same, you know, prime numbers. We only write the different prime numbers. It means all prime numbers are different from each other, okay? And in this case, we only have a 2, 3, and 5. That's it. Now we fill in the highest power. Okay, first you look at number 3 above. Okay, 3 equal to 3 times 1. Okay, and 3 does not appear in 20 and 12. In 20, so we don't need to care about it. And 3 appear again in 12, but the highest power of 3 in 12 is also 1. Here, the power here is 1, and the power here also 1. So the highest power is 1, right? So that's why for the number 3 here, the power is 1 as well. Okay? And now we look at, because we need to find the highest power, right? We need to fill the highest power, but because the highest power is 1, so for LCD, I mean the least common denominator, number 3 also appear with the highest power as 1 only. Okay? And now we go to the prime number 2. So if you look at here, so 3 times 1, we don't have a 2 here, so don't care about it. And you look at 20, so the power of number 2 in 20 is the power 2, okay? And if you look at 12 here, so the power of number 2 in here also 2. So it means the highest power of prime number 2 is 2. So you fill in 2 here. Okay, so power 2. Okay, so now we look at number 5. It's a similar thing. So number 5 does not appear in 3. Now, number 5 does not appear in 12. It only appears in 20. And the highest of number 5, the highest power of number 5 in 20 is 1. So that's why the number 5 here also has a power 1. Okay, so that's it. That's the least common denominator. Okay, so 3 times 2 power 2 times 5, and 3 times 4 times times 5, because 2 power of 2 is 4. So it's a 12 times 5, and equal to 60. So that's the least common denominator. Okay, and now we'll add them together. So after we find the least common denominator, we just change the original fractions to new fractions with the same denominator, right? So now let's go back here. We have a 1 over 3. We have a 7 over 20, and then we have a 5 over 12. Okay, so how can we change those fractions become a new fraction with the denominator, the same denominator 60 we found above? Okay, so for 3, in order to how to turn 3 to become 60, okay, the way to do it is you only need to divide 60 by 3, and you get the answer is 20. So in order to turn 3 become 60, you need to times both the top part and the bottom part by 20. So 1 times 20, 3 times 20, and it equal to 120 over 60. Okay, and how about the second fraction? How can you turn 20 here to become 60? So you need to time it with 3, and because you time the bottom bottom part with 3, you need to time the top part with 3 as well. So you have a 7 times 3 over 20 times 3, and it equals to 21 over 60. Okay, and for the last fraction, for how can you change 12 to become 60? So the easiest the way to do it the same thing, divide take 60 divided by 12, then you get answer is 5. Okay, so 5 times 12 is a 60, so it means you need to times 12 here with 5, you times 5 here with 5 as well. So and then you have a 5 times 5 over 12 times 5. Okay, and the answer is a 25 over 60. And after you get this, now you get all the new fractions with the same denominator 60. So just add all of them together. (20 over 60 plus 21 over 60, 25 over 60. And the answer is 20 plus 21 plus 25 over 60. Okay, so after you get this, you add them all together, you'll get 4166 over 60. Okay, and it is 66 over 60. It means the numerator is greater than the denominator, so you can convert this one into mixed number by the same method we use, long division. Take the top part, divide by the bottom part, and you have a 66 divided by 60 is 1, and then you have a remainder is a 6. So we can fill in the quotient go here, the remainder go here, and the divisor go here. Okay, so that's the final answer. Okay, so hopefully the fraction addition lesson today is helpful to you guys. So next time we'll do additions from mixed number, but for mixed number it's just the same way to do it. The only difference is the whole number part. Okay, but we'll talk about it in the next lessons. So thank you for your watching. Bye for now.